Howdy, welcome to my project about algae biodiesel. This project is in fulfillment of Bio 111. Biofuel is a kind of renewable energy produced from the biomass of living organisms. Algae biodiesel is produced from the oil in algae. Algae biodiesel was discovered in the 70s during the energy crisis. How is algae cultivated to create algae biofuel? First of all, it uses open pond systems. What an open pond system is it's a large outdoor pond that leverages natural light and attempts to keep water flowing so that algae can continuously be brought up to the surface and harvest that natural light. This allows for increased photosynthesis, thereby increased energy, and thereby increased oils for the energy to be stored in. What factors need to be controlled to grow algae? This is a quote from the Department of U.S.'s Aquatic Species Program. I found this article on the web. Essentially, what it says is that pH, CO2, and temperature are crucial factors in growing algae. These are examples of open pond systems. This is a raceway pond. Raceway pond allows for flow all the way across the pond. This is a stirred pond. It uses a paddle, as you can see here, and it turns and stirs the water in a circular movement. Processing algae biodiesel. There are essentially three steps into processing algae biodiesel. These steps can be broken down further, as you can see here in this diagram, which I'll come back to. These are essentially what happens when you're processing algae biodiesel. First of all, you want to culture algae. You want to produce algae in mass and make sure it's the correct species that will produce the correct amount of oils without having to put too much energy to cultivate it. Once you have cultivated enough algae that will produce enough oil, you're going to extract the oil. There are three methods to doing this. First of all, you can use a solvent. The solvent will extract the oil from the cell without having to break the cell wall. Or you can break the cell wall by either using ultrasonification or by manually and using mechanics to break the cell wall. Once the oil is extracted, you want to refine the oil using transesterification, which is what happens when you allow the ethanol and a catalyst to react with the oils. Once this reaction takes place, there are two products, biodiesel and glycerol. Biodiesel is your fuel. Once these two products are created, you separate biodiesel from glycerol and refine it further to remove any leftover catalyst or glycerol. This is the diagram of this process. First, you're going to develop the strain. This is the species of algae that is most suited to this process. You want this strain to be easy to maintain, so it doesn't require too much energy to create the fuel, and you want it to produce a lot of oil. That way, more fuel is produced for less energy. You're going to want to nurture it with nutrients, sunlight, water, and CO2, and make sure it is managed correctly in the open pond systems. Once you have enough algae and it is producing enough oil, you're going to dewater the ponds. As you can see here, these ponds don't just have algae in them. They have water and possibly algae waste. So when you dewater the ponds, you're removing all the excess water. And when you remove the co-products, you're getting rid of all that waste. According to this diagram, that's going to be about 50% of what's left over from the water extraction. Now, once you're left with only the algae, you're going to extract the oil, which will become fuel. Once the oil is extracted, it's going to move on to pre-refining. The rest of the algae cell is residual biomass. This can be used for animal feed or other such things, but it is no longer useful in the process of creating biofuel. Now, In this purifying process, the algae is reacting with ethanol and the catalyst in order to create biofuel. The biodiesel is then refined and separated from glycerol and leftover catalyst. This can become gasoline diesel jet. And according to this diagram, that accounts for the other 50% of what is left over after the dewatering. Now, this biodiesel is not fully researched. As you can see, there are plenty of strands of algae to continue to research in order to find the best strand that is most suited to producing biofuel. This strand should produce lots of oil and be easy to maintain. Research is still in its early stages, but so far, the prospect of algae biodiesel is very promising. Currently, algae biofuel is still much too costly to produce and consumes more energy than it creates. This is why we want a strand of algae that will produce more energy for more oil. It will be less costly to maintain. The economic benefits of algae biodiesel include having a little to no carbon footprint because algae is a plant and consumes CO2 during photosynthesis and therefore consumes CO2 in order to create energy, which then emits CO2 when it's being burned. Therefore, there's a net zero CO2 in this system. Currently, if algae biodiesel became more widely used, it would be an economic strain because there is no strand that we have discovered yet that is conducive to producing a net gain of energy. However, once a strand that is conducive to producing a net gain of energy, one that can produce more energy than it takes in maintaining, algae biodiesel would be less expensive and would allow for less reliance on foreign gas and decrease CO2 emission because again the algae biodiesel carbon footprint is close to zero. Therefore, once it becomes a realistic source of energy, it would greatly benefit the natural economy. What programs are there about outreach of biodiesel? One effort to communicate the use of algae to the public is Algae Technology Educational Consortium, or ATEC. This institution is a result of collaboration between the U.S. Department of Energy, the Algae Foundation, and the Natural Renewable Energy Laboratory. ATEC strives to create jobs and educational opportunities centered around algae's potential to be a source of nutrients, fuel, and other bio-based products. This organization outreaches to classrooms K through 12, to college students, to graduate students, all the way to creating jobs for highly qualified researchers for the sake of awareness and supporting the development of algae industry. Next step. My evaluation of the current situation is that the focus should be on researching and engineering more strands of algae that would be easier to maintain and that produce more oil. This should help find a strain of algae that will produce a net gain of energy, one that produces more energy than it consumes during maintenance. This leads to my action plan. With this analysis in mind, my plan of action would be to fund ATEC, which produces researchers, then feed those researchers into the algae biodiesel project. These researchers could then be split into two teams, one researching algae that already exist, and the other team would be testing new strains of algae and creating strains of algae that are best suited to our goals. These two teams combined should be able to find a strand of algae that is best suited to producing biofuel. Next, I would hire engineers to construct more energy efficient ponds and refiners so that even less energy is required to produce fuel. My action plan as a whole is again engineered so that we will find a strand of algae and a maintenance system that would produce a net gain of energy, one that would not consume more energy than it produces. This way, algae biodiesel could become a viable energy option. In conclusion, we talked about what algae biodiesel is, how it is cultivated, how algae biodiesel is produced, how close we are to being able to use algae biodiesel widespread, what would the impact be on the carbon footprint, and the economics, both natural and fiscal, and what efforts there have been to spread awareness, as well as my analysis of algae biodiesel and my proposed plan of action. Thank you so much for listening to my video. I hope you learned something new about algae biodiesel and enjoyed this as much as I have.